Alright, here in this next video, in section 11.2, we're going to look at question number 4. This problem says that the area of a circle is given by area equals pi times radius squared. How are the area and the square of the radius related? What is the constant of proportionality? And if we double the radius, what happens to the area? Okay, so you'll notice here there's a square on one of the variables. That makes this problem a little bit different than what we've seen up to this point. Now I've abbreviated that formula up here. Now if we do go ahead and look at the ratio of area to r squared, kind of like what we did in problem number 3, notice here that r squared will divide over, leaving us with just a pi on the right hand side. Now pi is this very special number, approximately 3.14. What we really care about here is that this number over here is a constant. And what this is really saying then is that a and r squared, these two things now, have a constant ratio. And so because of that, that means that a and r squared vary directly. Alright, so then what can we say about the constant of variation? Well, that's just the k value, right? And looking at, so the constant of variation, also known as the constant of proportionality, and this problem does say use that language proportionality, so I'll go ahead and use that as well, but both are used here. This is just the k value, and looking back here, right, it's the ratio of the area to the square of the radius, right? The area can change, the radius can change, but this ratio, the pi value, is the thing that's fixed. That's our constant. Okay? Alright, great. And then finally, if we were to double the radius, what would happen to the area? Alright, so here is a picture of a circle, and its radius is r, the area there is a, and what I'm going to do is I'm going to go ahead and form a new circle by doubling the radius, and we want to figure out what is going to happen there to the area. Okay, and so what we can say, right, really just taking this relationship we derived there, carrying that over, I'm going to say, okay, the ratio of the original area to the square of this original radius is going to come out to be pi. Okay, now that same relationship is going to hold for this new circle, except now, right, the radius is not r, it's going to be 2r, right? So we know that the area of the new circle divided by the square of its radius, which is now 2r, this is going to have to come out to be pi. And so the question is, what do I need to put up here, right, in order for the ratio of the new area to the square of the new radius to still come out to be pi? Well, to answer that, what we can do is just observe that this thing right here, okay, the 2 is getting squared as well as the r. So this thing really is 4r squared. Okay, so now coming back up here, in essence, what are we doing, right? The effect of that square on the 2 is a multiplication of r squared by 4. So that's really the same thing as taking this original relationship and multiplying by 4 there, and then to counteract this multiplication of 4, I'm going to go ahead and have to do the same thing up there. So we're going to get a factor of 4 up here is what we're seeing, multiplying that original area here. So when all is said and done, right, if the radius is doubled due to the square on the radius, our area then will be multiplied by 4, and this new area is in fact 4 times the original area. Okay, now this kind of relationship where we have a square involved is known as quadratic variation. Okay, and so here what we're going to say more generally is that y and x will vary quadratically if not the ratio of y to x now, but the ratio of y to the square of x is a constant. Okay, so another way we can write this relationship, just moving the x squared over, is to say that y is equal to k times x squared, right? And the graph here is actually a parabola, right? So this is not linear variation, what we saw earlier. This is now quadratic variation, okay? And down below here is an illustration of this sort of thing. So I have a table of values, and if I go ahead and I look at, say, the ratio of just y to x, okay? Well, if I do this with the first pair, I'm going to get 2 to 1, which is 2. And then with the second pair, I'm going to get 8 to 2. That's 4. Okay, so here I notice that this ratio is not constant. So we would say, right, that this is not direct linear variation like what we saw before. However, if I go ahead and look at the squares of x, so I'm going to make a little additional column over here and look at, say, x squared. Okay, this would be 1, 4, and 9. Okay, let's go ahead and look at now the ratio of y to x squared. Okay, now we're going to get what? Well, a 2 to 1 ratio still for the first pair. Then it's going to be, okay, 8 to 4, that's a ratio of 2. And then 18 to 9, okay. So I see here now, right, this ratio of y to x squared is always the same. Y over x squared is 2. This 2 would be our k value, the constant of proportionality. And another way to write this would be y is equal to 2x squared. Okay, so this is a good example of quadratic variation. And lastly, just like what we saw with the doubling of the radius and that multiplied the area by 4, we're going to see that same kind of thing here, again, due to that square on the x. So for example, let's say I doubled 1 to 2. Am I going to be doubling y? No. Here, what I'm doing is I'm multiplying that 2 by a factor of 4. Again, the 2 gets squared there, so that multiplication factor is 4. All right, that's a good place to stop.